Hey everyone, today we'll be solving one question from the residue theorem. It's based on the integration, and this function value has been given, and it has to be evaluated over a counterclockwise circular counter, right, at the pole, and we have to assume one imaginary point which is z is equal to I, which is the iota. So if we try solving it, first of all we will write it as f of z. If we assume 2z4 minus 3z cube plus 7z square minus 3z plus 5, and if we put value of the iota in place of the z, it would become 2i4 minus 3i cube plus 7i 7i square minus 3i plus 5, right? So next we know that c is equal to I is a singular point, right? So if we assume the value of the iota over here, so it would become 2 times of iota square would be -1, and -1 into -1 would be 1, minus 3 into iota square would be -1, and -1 into iota it would be minus iota, plus 7 times of -1 minus 3 iota plus 5, right? And if we solve it, it would become 2 plus 3 iota minus 7 minus 3 iota plus 5 is equal to 0, right? So now if we apply the Cauchy residue theorem on this equation which has been given to us, it would become circular integral of 6z divided by 2 times of z4 minus 3z cube plus 7z square minus 3z plus 5, and differential with respect to dz is equal to 2 pi I, which is residue of at z is equal to I. So this is the Cauchy residue theorem equation, where if we write it, let me just separate this out, where it would become at z is equal to I. If we differentiate it, z approaches to I, right? And if we solve it, it would become z minus I 6z divided by 2z4 minus 3z cube plus 7z square minus 3z plus 5, right? So if we differentiate it, it would become limit of z approaches to I 6z square minus 6z iota divided by 2 times of z4 minus 3z square plus 7z square minus 3z plus 5, right? Now if we put the value of iota in terms of the z, it would become the form of the 0 by 0. So again, if we differentiate it, it would be limit of z approaches to I 12z minus 6I divided by 8z cube minus 9z square plus 14z z minus 3, right? Now further it would become 12I minus 6I divided by 8 times of iota cube minus 9 times of iota square plus 14 times of I minus 3, right? Now next 12I minus 6I would be 6I divided by 8 into minus iota, sorry, so here it would become 6 iota divided by minus 9 of minus 1 plus 14 iota minus 3, right? So then it would become 6I divided by 6 plus 6 iota. So if we take common 6 outside, it would become iota divided by iota plus 1, right? So therefore if we take the whole equation, 6z divided by 2z4 minus 3z cube plus 7z square minus 3z plus 5 times of dz is equal to 2 pi iota into I divided by I plus 1, right? Now if we solve this, it would become 2 pi into minus 1 divided by iota plus 1 is equal to minus 2 pi divided by iota plus 1 into iota minus 1 divided by iota minus 1, right? On further solving it to become minus 2 pi to iota minus 1 divided by iota square minus 1 is equal to minus 2 pi iota minus 1 divided by minus 2. So if we solve this out, it would finally become minus 1 plus iota, which is our final answer. This is the A option, right? Thank you.